Good afternoon. Thank you for coming for this press briefing. On behalf of SBS Transit, we would like to apologize to all the commuters who have been greatly inconvenienced by the disruption that we faced this morning between Harbourfront and Dhoby Ghaut. We did the checks, and we first estimated that it could take us up to about 12 o'clock, and later we have to delay to 2 o'clock, right, because it took longer than expected to repair the overhead cables. Subsequently, just as we were about to resume the service for 2 o'clock, we discovered another technical fault. And as a safety precaution, we decided to do one more check and fix that fault before we resume service at 16:35. We are truly sorry about this incident and the disruption and the inconvenience caused to the commuters. I would like now to ask my EVP of Rail, Mr. Juay to explain to you the technical part about the cause of the incident this morning.
Good afternoon. Good afternoon. In the next few slides, I will give you a short briefing on what happened and some of the sequence of events and what do we do in our recovery process. Okay, I think first let me just give you a bit of an explanation of some of these terms that we will use. Right. Later on, I think we may use some of this abbreviation like OCS. OCS is actually the overhead catenary system that is a network on the top of on the ceiling on the tunnel that provide power supply for the train to operate. Right, next term that later on we will see is we call it the BWA. This is called the abbreviation for balanced weight anchoring system, which is a tensioning system provided to suspend the OCS system at the top of the tunnel. Right. So these are the two terms we will use. Right. Now, first, let me just elaborate the location of the incident. Now, this is a schematic diagram where you can see that this is Harbourfront Station. This is Outram Park Station. This is the southbound direction tunnel. This is a north direction tunnel. Okay. Now, between Outram Park to Harbourfront, the distance is approximately about 2.2 kilometers in length. Now, the location of the incident occurred at approximately 1 kilometer in the tunnel, right? In the sub-tunnel from this is the area we call the head wall of Outram Park Station, right? Now, it's a marked here, rough location. Now, this is a OCS sector where there are two BWA. That's a balanced counterweight anchoring system, right? The location is approximately about a kilometer away from here. So next one, I think we'll go a bit into more detail. Now, this is how a schematic of a BWA look like. Right? It's actually a dead weight. Right? I think this one is, there are two of them. One is for the overhead wire through a pulley system, right, to provide a correct tension for the wire. Right? And there are support along the tunnel to hold it up in upper part of the tunnel. Right, the train actually have a power collection system which run and slide along this wire to collect power. Right. Now, this is the balance weight system. What actually happened was that there are two of these systems for one sector. One is for the main contact wire for the train to collect its power. The other one is a slightly smaller system, slightly higher than this, actually feeding power onto this system. Now, what we found this morning was two of this system. Now, with this tensioning wire, which is a stainless steel cable from here go all the way up here to tension the cable, two of the stainless steel wire was snapped. So, okay, this is okay. This is a picture of how it look like. This is not in the actual location, but it's a system set up inside that. Now this is the PWA. You can see that here is two counterweight here. Go through this stainless steel wire, go to the pulley system, where this go to a insulation part and connect to the live part of the power supply system. This is how actually a system setup look like. But this is not the actual location. This is in a different location. But the setup is exactly the same. Okay. So the part that broken is somewhere here. This is a stainless steel cable. Right. Okay. Next.
Yeah. We'll give you copies of this slides later, okay?
Okay. Now, besides the two stainless steel cable was broken because of the weight of the copper wire for the power connection system, the cable sat down. Right to I think one of the cable was on the tunnel floor. The other one was halfway suspended in the air. Right. It also caused some of these support arm along the tunnel to be misaligned. Right. Okay. Now this is a schematic diagram of how it looks like. In a normal situation, this balance weight, right? There are two of them. One weigh about 860 kilograms, the other about 700 kilograms. Right now, connected through this stainless steel cable to the power supply system on top of the tunnel ceiling. Now this was a cable that snapped, so resulted in this balance weight drop, and it lost tension, so the cabling, the wiring system there also correspondingly fell. So I think that's what had happened. Okay. Now these are some of the pictures that we have taken during this morning when we went in to inspect the failure. Right, these are some of the pulley. You can see that because of the weight, it is actually distorted, right? And this is the weight. This is the weight itself. You can see that. Right, there's supposed to be a cable connecting here. The cable has snapped, so it actually dropped. It's supposed to be somewhere hanging in that sort of location. Right, this another two picture. I think you can see that the two, because of the two balance weight cable snap, this wire, overhead wire, fell off. Some of this actually come down to the tunnel floor. Right. And this is a picture taken along the tunnel. You can see that all these wires are supposed to be on top of the tunnel. They actually have slackened and fell off. Okay. Now these are some of the arms that I mentioned. You can see that normally they are supposed to be in a perpendicular position or slightly in that sort of angle, supporting all this wire. You can see that because of the balance weight have lost the tension, the cable have dropped, the weight actually have the misaligned and distort some of this. So in the recovery process, we also, besides setting up the cable, we also have to inspect all this. Now this is a photograph of the stainless steel cable that have set off. Okay, these are some of the pictures taken during the recovery process. So with the two balance weight cables snap off, we actually have to set up high level platform to reconnect all these the balance weight and all the overhead cabling system. Now you can see that in the tunnel, all these are manual work, all has to carry out manually, right? And this is a picture of them trying to set up the reattach the balance weight. This thing weighs about 800 over kilogram. So we need a lot of manpower in there. The process is labor intensive, and we need to rework on two set of this balance weight system in the tunnel. Okay. And these are some other pictures just to show that they have to go up to high level. All manual work, got to carry out all the heavy pulley and all the stuff and reconnect them. Okay, so that's some brief sequence of the event might happen. Okay, at about 5 a.m. this morning, that's slightly before 5 actually, when we finish our engineering work and we turn on the power supply, we noticed that some anomaly. So actually we send people in to check on the system, and that's how we discovered that two of these PWAs actually have a snap cable. Right. And I think upon identifying this, we commence our repair work immediately, and also we have activated our alternative mode like shuttle bus services, or within half an hour of it discover this incident. Right? I think that's the part that we talk about this. I think bus OCC also during the process have arranged for the free shuttle bus services, and also at the same time we also allow free boarding of the regular buses by passing those affected stations. Okay. And also throughout the process, I think there were regular updates that we had provided to inform commuters of what happened and what are the expected time and recovery, things like that. So I think further, this one in the station, we also make announcements to inform commuters affected. We also put up signs at the station entrances and things like that to inform commuters of the service disruptions. In total, we have deployed 74 buses to provide the free shuttle services during the incidents. And also, we have mobilized 131, we call it goodwill ambassadors, to the station, to the affected stations, to provide information to the affected commuters. Okay. Now, actually, the repair work of the two balance rate assembly, we have completed it actually at around 1300 hours. That means 1 p.m. Why there was originally we say that we expect we can recommence service at 2 o'clock, and subsequently we have to delay it because after we finish the work, we carry out a safety check to make sure that everything is in order and safe to operate trains. Then we identified that there was another problem. Right? We identified a third problem that was due to a cable, possibly a consequence of this incident, also got damaged, which is located approximately very close to Outram Park Station, almost a kilometer away from where the OCS development. So we have to proceed to rework that. In fact, the investigation process take a bit of time. So at about 3 o'clock, right, we actually identify where was the location of the damaged cable, and we have done some repair to rectify the situation. And after that, we actually just carry out tests. First using an engineer train, then subsequently an electric train without any passengers to verify, to ensure that the system is fit and safe for operation before we recommence full service at 16:35 hours. So that's a brief account of the event.